Hey guys, so this is all about parent function transformations. So the previous time we talked about parent functions and what they looked like. Now our objective is to transform those parent functions into new graphs. So the first thing we need to discuss are what these things actually mean. Okay, so how does the h affect the graph? In the graphing calculator activity, you need to notice that the number inside the parentheses. So if it's a plus h, okay, that if it's a positive number, it moves the graph left. If it's a minus h, it moves the graph right. Okay, then we're going to go through examples of these. If the k is outside the parentheses, okay, it's not directly affecting the x, okay? If it's a plus k, moves the graph up. Okay, if it's a minus k, moves the graph down. Okay, so the k is the up and down. You can think of that almost as like the y-intercept in a linear function. The tricky one becomes the a. Okay, the a, if it's positive, it opens up. If it's a positive a, you're never going to see a plus a. But if it's a positive a, the graph is I'm going to say faces up. Okay, means that it's gonna. If it's a quadratic, it's gonna open up like this. If it's absolute value, it's gonna open up like this. Okay, if it's a negative a, it's gonna face down. Means if it's like this, it's gonna flip. Okay, if a is greater than 1, 2, 3, 4, 5, 6, any of those, okay? It's going to get narrow, okay? You can think of that as slope, okay? A is basically like slope, okay? So if A is 2, it means it's going to rise 2 over 1 versus the up 1 over 1. It's going to get twice as steep. Okay. If a is a fraction, meaning that it's less than 1, okay, or bigger than 0, it's going to get wider. Again, if we think of it as slope, if it's 1/4, we're going to go up 1 over 4. It's going to make the line tilt so it's wider. Okay. So we're going to be graphing, and we need to identify the function first, and then we need to describe how it moved. So the constant function, a constant is just a number. You're most often y equals a. Okay, y equals 4, y equals 5. It's that horizontal line. Okay. Cross out identity function. Okay, this is a linear function. Okay, it's anything that's like y equals mx plus b, that form. Absolute value function is has the absolute value bars. And quadratic function is anything squared. Okay, so the first thing is to identify the problems as linear, any of these. Well, this is linear. Okay, well, what happened to this function? Normally this function has a slope of 1 and is right here. Well, really, I just took this function and I moved it up. Okay? How much I moved up? I moved it up 3. So how am I going to write that? Well, the slope didn't change. Okay? And I put y equals x plus 3, because that's my k, okay? Because moving it up just means that I'm adding 3, okay? Here, it's a quadratic, okay? Normally, my graph would look something like this. Well, what happened to that graph? I took it and I moved it down, okay? So this got moved down 3. So now I'm going to start writing my formula, okay? And if I'm moving it down, that's my k. So I'm going to write y equals x squared minus 3. And nothing else changed with it. So what I wanted to point out, these are all just adding or subtracting, okay? Those are my k values. So again, this is linear, and it's moved up 5 from its original point. So all I'm going to say is y equals x plus 5. While this one is absolute value. Now, this one got moved down 3. So it's going to be y equals the absolute value of x minus 3. And then I can go through and figure those out there. The trick comes with 4, 5, and 6. Okay? Now, the tricky part about 4 is that it didn't move anywhere. It just kind of, normally it's like this. Okay? And now it's pointing the opposite direction. Well, number 1, it's still linear. Okay? Didn't move anything, so it's not h or k. Now, it's that a. It's that flip. Okay? So this is literally just taking this and flipping it to the other side. So this is going to be negative x. Okay? The negative 1x. It's going to be the flip of that. This one, and I'm highlighting this one, okay, is that constant function. It's that y equals a number. In this case, it's 3, because it's at the 3 mark. Okay? Here, it's the absolute value function. Okay? Well, absolute value function normally looks like this. Each side goes up 1 over 1. Well, now it goes up 2 over 1. Up 2 over 1. It creates a steeper V. So that is where my A comes in. That is going to be y equals 2, think of it as slope, 2 absolute value of x. Okay? So it's twice as fast moved. So to give you a little bit of help with this, now I have to graph this. Okay? So if I look at this, this is absolute value. So normally it's going to look like its parent, like this. But now I have this negative in front of it. The negative is just going to take this and flip it. Okay? So normally my points are negative 1, 1, 0, 0, and 1, 1. So I'm going to take it and I'm going to flip it. Okay? My 0 isn't going to flip. It flips in the x-axis. These points, on the other hand, are going to flip. It's going to be pointed upside down. So my new points, my x's never change. Okay? it's my y's that change. Now, my y's become those negatives, okay? I didn't change my x value that I put in, I only changed my output, and it's flipped. So that's what you have to do with these, okay? Remember, something like this, the -4, if it's not in parentheses, it's the k, which means this graph is just moved down 4. So I'm going to go 1, 2, 3, 4, make the point, and draw my linear function. Here, it's inside the absolute value. It's happening directly to x. So that's my h. Okay? And it's positive. So this is going to be moved left 5. Because positive in here means it's moving left. So instead of having my absolute value function here, I'm going to take it and I'm just going to move it left 5. And it looks exactly the same, just moved left 5. Here, it's not happening directly to x. It's not in parentheses. So that's my k. So it's -3, so it's moved down 3. So normally, my graph looks like this. Now I take it and I move it down 3, it looks like that. And that's all you have to do when you're moving this stuff around. And it's to help you figure out how do functions move, left, right, up, down, that sort of thing. So please complete the practice problems for this, okay? And come in with any questions. Remember, these are my A's. They affect that slope, okay? So this one's going to get wider, this one's going to get steeper, all right? Please write down any of your questions on little notes so you can come in next class knowing what you had trouble with. All right, thank you.